Hi all, welcome to the YouTube channel Mechanical Engineers. So in our previous video, we discussed about introduction to positive displacement pumps and the types of positive displacement pumps. We also discussed the first category of positive displacement pump, which is reciprocating pumps. So today we shall be discussing about the next category, which is rotary pump. In rotary pumps, relative movement between the rotating elements and the stationary element of the pumps causes the pumping action. So as you can see, this is an rotary pump. So in rotary pump, relative motion between the rotating elements and the stationary element causes the pumping action. So this operation is basically different from the reciprocating pumps where the valves and the pistons are integral to the pump. So here, as you can see in this picture, these are the two gears and they are rotating between a stationary part and which is causing the pumping action. So there are basically different categories of the rotary pumps. There are internal gear pumps and there are external gear pumps. So in the external gear pumps, there are two meshing gears that rotate inside the fit casing. As the teeth separate, the space between them increases and sucks a certain amount of fluid. The trapped fluid move with the teeth until then till they get in contact again, the surface between them becomes zero. The only way the liquid has is the delivery port. So, so this is clearly visible in our this picture also. There is a fluid getting entered inside the pump, and as these gears rotate, the fluid also rotate along with the in the clearance between the gears. So as they rotate faster, as the gears also rotate, the only exit media for the liquid is the delivery port. So this is the basic principle of operation of a gear pump. However, in the internal gear pump, the internal gear pumps works on the similar principle, except the two Lincoln gears sizes are different. One revolves within the other. The rotor is the larger gear and also an inner gear, and it has the teeth projecting inside. So as you can see, there are two gears. One is the bigger gear and another is the smaller gear here, and they are rotating. The inner gear rotates within the bigger gear. The fluid that comes into the cavities and as well as the trap between the teeth of the gear, because the gears continue for the rotating next to the casing of the pump. The trap liquid can be moved from the inlet to the discharge side. As you can see, the fluid is getting entry from inside. As the gears rotate, the only way for the exiting of the fluid is the discharge port. So another category of the positive displacement pump is a lobe pump. So lobe pump are similar to the external gear pump. In this, the operation is that the fluid flows around the interior of the casing. Unlike the exterior gear pumps, however, the lobes do not make an contact. So the contact, there is no, as you can see, these are the two lobes. As the fluid gets in, the lobes are not in direct contact. There is a slight clearance between the two lobes, and as these lobes rotate, and the only way the fluid has the exit is the delivery port. Screw pumps are also a category of the positive displacement pumps. So screw pumps are equipped with the screws that mesh together and rotate with the cylindrical cavity or the liner. The fluid enters the suction side of the pump and then move linearly across these intermediate screws to the discharge side of the pump. The clearance between the screw and the liner are very small, hence the fluid gains a pressure while moving through the pump. So, As you can see, these are this is the twin screw pump. As the fluid gets in, it get the fluid rotate within the these screws, and there is a thin finer clearance between the external casing and the screw, which causes an increase in the pressure. And as the rotation increases, the only way out for the liquid is to get discharged from the outlet port of the pump. So basically, screw pumps are basically more of one kind of used in the oil industries because for the pumping of the heavy, thick additives, which have the viscosity of range of 8,000 to 10,000 CST. The vane pumps are also a category of the positive displacement pumps. The pumps consist of cylindrically bored housing with a suction inlet on the one side and the discharge outlet on the other side. The cylindrical shaped rotor with a diameter smaller than the cylinder is driven about an axis placed above the center line of the cylinder. The clearance between the rotor and the cylinder is small at the top, but it increases at the bottom. The rotor carries the vanes that moves in and out as it rotates to maintain the sealed spaces between the rotor and the cylinder cell. And the vanes trap liquid or the gas on the suction side and carry it to the discharge side. As you can see, these are the vanes, and they keep touching the internal part of the cylinder, and it keeps moving from the upward to the downward direction. So as they slide upward and downward, the clearance they carry the liquid or a gas on the suction side. These vanes carry liquid and gas, and and once it rotates and reaches the discharge side, these liquid and gas are discharged from the outlet port. So thank you for watching the video. We shall be covering more about pumps in our next video. Thank you for watching.